So in this video, I'm going to try and answer a question using R. And my question is there a gender gap in PhD publication rates? Are male students more likely to publish over the course of their PhD than female students? This is quite a nice question that I can address using lots of tools that we've seen so far in R in terms of reading in data, keeping good track of my commands using a Markdown file in RStudio, doing some visual exploration using ggplot, and then maybe extending it a little bit using some statistical hypothesis tests to try and understand this relationship a little bit better. This generally fits into quite a nice framework that you might see if you look at R for data science or other tidyverse resources, where they've got this sort of import, tidy, explore, communicate kind of flow diagram. And this is quite a nice microcosm of that. Now we've learned all the tools that we can start to build up this framework and start to think of how these different items link together. So if I just go back to my question for a second, I have been busy collecting data from 915 biochemistry PhD students from America in 1996. You can probably guess this is not my data. This is some publicly available data. You can read the article where it was published from back in 1997 if you're interested in diving into this question in more detail. But for now, I'm just going to start using this as an example to try and show you what a kind of workflow looks like when we're using R. Okay, so I've now loaded up R, and the first thing that I'm going to do in RStudio is I'm going to create a new project for this task. This is just a really good way of linking together the files and the particular project that you are working on so that you don't get lost and confused in terms of which script files go where and version control, and lots of reasons why using projects in R is a very good idea. So I'm going to click here on New Project, and I've already stored my data here in a folder called PhD work. So I'm going to set my directory for the project as this folder here, and this should now load up, and it will show me that I already have my data file in this folder, PhD publications.csv, but I don't yet have it in my R environment. So the first thing I'm going to do, I'm going to cheat a bit for reading in the data. I'm going to use the import dataset menu. I know already it's a CSV file. It's a nice clean thing. I don't need to worry too much about the format, so I can just use this from text base option. I'm going to click on my data, and PhD publications as a name. This is quite long. I'm just going to call it PhD. It's a little bit shorter, a little bit easier to work with later, but everything else in terms of reading this data in, this looks okay. We can see the variables that we're going to have to work with here. We've got the number of articles published, we've got the gender of the student, we've got whether they're married, the number of children, we've got something to do with the prestige of the university and the course that they're taking, and we've got a number of the mentor in terms of how many articles they published. So for now, we're just going to focus on these first two columns, but we've got some other data we could want to play with in the future. So I'm going to press import. And you can see this brings it in. When I do that, I happen to see three things at once, where in my environment, I've now got something here called PhD, 915 observations, 6 variables. My data has popped up here in the top of this window here, showing me in a spreadsheet format. Looks like it's read in OK. Most important thing though, in the console window, the command to read this in, it's been written for us. But I also want to take a copy of this command, and I want to start creating my own script file, because I want to keep my commands together. I want to sequence them together in a nice structured way, so that when I come back to this tomorrow, or if I share it with someone else, I can then read it in just through running my script file, rather than saying, oh, first of all, you've got to, read it through the import data set, and you've got to change the name of the data to be PhD, and so on. So I'm going to copy this, and I'm going to create a new file. So I'm going to click here and say I'm going to create a new R Markdown document. I'm going to create an empty document, just so it's nice and blank and clean. So remember, in these R Markdown documents, to begin with, you can write anything you like in the main body of here. So I'm going to just write at the top, import data. And beneath it, I'm going to add a chunk to say, this is my R code for reading in the data. So anything outside of these R chunks, I can write whatever I like. So I should probably, even before import data, put in a title saying PhD, if I can spell it correctly, gender gap analysis. And then stage 1, import data. And here I now have my chunk. So instead of going through the menus, if I now want to run it again, if my data changes, if I go away and come back, I just have to press my little green button. It's normally a good idea to also summarize your data, just to check there's not going to be any major issues when you bring it in. We've had a look at it in the spreadsheet format, but if we look at it in the summary format, we can see, okay, the articles, this has been treated as a number. We're getting our summary statistics. The same for number of children and prestige and mentor. Gender and marital status, these are coming in as characters. We might want to tidy this up and convert it to factors, but there's nothing in there which is going to be too much of an issue if they are set up here as characters instead of factors for the analysis we want to do here. So I'm not really going to do too much tidying of the data. What I am going to do in my setup step, though, I know that I am definitely going to want to use the dplyr library. I know I am definitely going to want to use the ggplot2 library. So I'm going to make sure I include these way at the top of my Markdown file in the very first setup chunk so that these libraries have been loaded in for me to work with. Otherwise, I won't be able to access all of the nice dplyr and ggplot2 functions. If I don't have them already, I can of course go across to my packages and click on install and then install it from the internet. But since I've already done that for dplyr and ggplot2, I don't need to do that again. So now I've got my data in, I've loaded my packages, I'm happy with how the data looks. Let's start trying to answer my question. And so the first thing I always want to do is make some plots and do some exploratory data analysis using graphs. So I'm going to explore my data, and it's going to be part 2, not part 1. So I am going to first of all think that, okay, I've got this number of articles variable, I've got this gender variable, I'm going to have to make a plot of these two. And I'm a good statistician, so I'm probably going to start off by making a box plot. So if you remember how the ggplot syntax works, I put in the data, which is PhD, and then I set my aesthetics. And if I want to make some box plots, I'm probably going to set articles as my Y aesthetic and gender as my X aesthetic, and then use geom box plot. I don't really care to do too much more customization here. These plots are just for my own exploratory purposes. I don't really care about colors and labels and titles, since the default output here is good enough for what I'm looking for. So if we're looking at the distribution straight away, there's a few things jumping out at me, which is, first of all, we've got a lot of data down here at 0, 1, 2, 3 articles. Up here, there's some very strange people who seem to have published 16 or 19 or even 10 articles over the course of their PhD. I'm not quite sure how, but well done them. But this is giving us a slightly strange looking distribution immediately, where we can see our boxes really clustered down here at the bottom. And another thing that's kind of jumping out is we can see the bottom of the boxes, they're at 0. So we've got quite a lot of zeros. At least 25% of our female PhD students and at least 25% of our male PhD students did not publish over the course of their PhD. And again, the median, this is identical. This is going to be 1, I think, for both female students and male students. The distribution may be slightly shifted. All we see is maybe the upper quartile is a bit higher for males, and all of these very high values are on the male side rather than the female side. So there might be a bit of a difference when we're comparing the distribution here of articles, but not a huge difference immediately. So maybe what I want to consider is, instead of a box plot, let's try and more explicitly look at the distribution by perhaps doing a histogram. So I'm going to do another chunk here for comparing the histograms of the number of articles by gender. So here, if I'm thinking of doing a histogram, when I'm thinking of how I'm going to map this up, it doesn't really work to have gender on the x-axis and articles on the y-axis. we definitely need to have articles on the x-axis, but I'm not going to set gender on one of the aesthetics. I think I'm going to put gender into facets. So I'm just going to have x equals articles, and I'm not going to map anything else. I guess just to make it look a little bit nicer, I might put fill equals gender so that they're different colors. And then I'm going to use a geom histogram. And then I'm going to use a facet wrap. And remembering my tilde and splitting that by gender. And we can see here kind of something a little bit strange. We get a warning message. You often see this warning message when you use geom histogram. And in this case, it's kind of important because there's actually a weird gap you can see between the 0 and the 1, because it's forced it into 30 categories, but we're only up to a maximum of 20, so the categories are actually smaller than 1 unit, so sometimes we've got kind of artificial spaces being created. It's kind of a rare time where ggplot is not necessarily doing something sensible. So I'm going to change in here bins to be equal to 20, just so that now this is perhaps a bit more of a realistic depiction. We don't have those spaces in real life because we've got lots of people with 0 and lots of people with 1. So looking at these distributions, again, it's the 0s and 1s which are jumping out to me, especially as we're comparing female to male. Obviously, we're seeing a hugely skewed distribution. This is not a normal distribution by any stretch of the imagination. But if we look at the female side, we can see there's kind of a bit of a big jump from 0, which is the most common response, down to 1, down to 2, and then huge jumps after that, all the way down, only kind of 1 very high number. With the male side, we actually see, okay, it's more or less equal between 0 and 1, and then we see the kind of similar decline that we see on the female side as we're increasing the number of articles. Again, we look at this, we're not seeing a gigantic difference between male and female from looking at our exploratory data analysis. We might want to, at this point, calculate some summary statistics. So we can do a group by and summarize. And let's just have a quick look to see how different the mean number of articles compares. So I need to group by gender and summarize the mean of articles. So if I run that, I can get my mean values where for the female respondents, it was about 1.5 articles published on average. For male respondents, it was about 1.9 on average. So yeah, the average is a little bit higher for male respondents compared to female respondents. But bearing in mind we have this slightly skewed distribution, is the average the best way of summarizing this? Since we can see for both cases, 0 was the most common response. Always before doing any kind of formal statistical hypothesis test, we need to be doing this data exploration. We need to kind of not be too surprised by the time we get to our analysis part of the analysis, if you like, our formal analysis. So everything I've seen so far has been leading me to the conclusion that doing a t-test would not be a good idea, because these are not even slightly normal distributions. So the assumption of underlying normality, completely out the window here. However, R is not going to do anything or stop me in any way at all from running a t-test. The function is very easy in R. It's just t.test, and I'm looking at articles, and I use the tilde to say articles by gender. Because I have a numeric y variable, articles, I have a categorical variable, gender, which has exactly 2 levels. This is exactly the perfect setup for a t-test. And I need to say it's coming from the dataset PhD. So this gives me my output. It's always worth remembering that the default in R is to use a Welsh t-test. So that assumption you sometimes learn about of equal variance doesn't apply here. We don't need to worry about that. We still need to worry about the normality assumption. So we do get, oh look, this is a very, very small p-value. Potentially, if I'm just doing the test without really thinking, I go, yeah, great, this is highly significant, reject the null hypothesis. We're seeing pretty good evidence of a gender gap in the number of articles on average. However, I am not trusting that result at all based on the distribution that we've seen. One approach to dealing with this could be that we go, oh, okay, non-normal, no problem. let's do a non-parametric test. And that can be done pretty easily, actually, in this case, because, again, the function to do it in R, very, very similar. I've just done a big old cut and paste. Cutting and paste is always your friend in R, because the only thing I need to change to suddenly unlock the world of non-parametric statistics, I just change the T to Wilcox. What I put inside the function is identical, and now I've just done a lovely non-parametric test of whether the distribution of articles varies by gender. Kind of a common misconception with this test is, oh, okay, instead of comparing the means, we're comparing the medians. This isn't true at all. If it was, this result of getting a significant p-value would be quite surprising, because we saw earlier the median for both genders in this data was 1 article. So it would be a very bad test that said you have a significant difference for exactly the same value as a median. What the Wilcox test does is it kind of converts all of our data into ranks. It says, okay, you have the highest number of articles, so you're rank number 1, then number 2, then number 3, and so on. So the distribution is less important in this case. Although we still have a lot of ties in our data, we've got lots of people with 0, lots of people with 1, lots of people with 2, and this kind of affects the power a little bit. It's also quite a hard null hypothesis to try to explain. You can see here the alternative hypothesis, the way it phrases it is location shift. We're saying, okay, is the distribution shifted in some way, but trying to sort of put the actual definition of the parameters underlying this, it's a little bit complicated to explain. And on top of that, if we go back to what is my actual question, am I even doing something sensible at this point, or have I gone down a weird alleyway? My question was whether there is a gender gap in publication rates. I haven't actually been looking at that so far. I've been looking at the data I have, which have number of articles and gender, but if I go back to my histogram, kind of what I'm most interested in are these zeros here, because the publication rate, what I'm thinking when I'm thinking that question is, okay, did they publish or did they not publish? I don't really care if they published 1 time or 2 times or 3 times or 4 times. I'm most interested in these zeros versus everyone else. So what I'm going to have to do is I'm going to have to think, okay, I got blinded by the data. Let me change my approach so that I can answer my question in a better way. And in this case, on top of that, analyzing the data in this way, the t-test isn't too good. The Wilcox test, it's telling me something, but it's not really getting to the crux of my question.